All right, so now we have a similar question, except with base, this case ammonia, so NH3 plus H2O is going to go to, and we're given our base value, so that means we've got H3O plus NH4 plus, right? So we're moving a hydrogen this way. Oops, sorry. Got carried away there. NH4 plus OH minus. There we go. Moving a hydrogen that way. There we go. All right, so our Kb value is going to be equal to our NH4 plus OH minus over our NH3 concentration. Again, water doesn't get included in our equilibrium expression. It's a pure substance. Okay, so we're given that the initial concentration of ammonia, here I'll do it this way. So I'm just going to rewrite this because I put my Kb right below it. Okay, so we're given that the initial concentration is 0.390 molar, and we would have 0 of these. Our change is going to be minus X in NH3, and then plus X in each of these. And so then at equilibrium, we're going to have 0.390 minus X, X, and X. And so then we can sub these into our equilibrium expression, which we've written up above, and also with the value. So in the question, we're given 1.8 times 10 to the minus 5, and so that equals X over 0.390 minus X. So we're going to take one simplifying step here and say that because our Kb value is so small, 10 to the minus 5, it's quite likely that X is going to be small. And so this is approximately 0.390. And so what this comes out to is 1.8 times 10 to the minus 5 is equal to X squared over 0.390. So then X squared is 1.8 times 10 to the minus 5 times 0.390, which is equal to, okay, so then X is the square root of this. And I have that value, so that would be 2.6495 times 10 to the minus 3. Okay, and so what is the percent, what is the pH, and what is the percent ionization? Okay, so we're actually in a spot to calculate our percent ionization already, as if we look, X is our OH minus concentration, and we've got our original NH3, and so our percent ionization is going to be 100% times our OH minus concentration at equilibrium over our NH3 concentration initially. So it's just how much of your initial NH3 has become ions, as a rationale for it. So 100% times 2.6495 times 10 to the minus 3 over 0.390 molar, and this will also be molar. So those will cancel. And then if we do this out, it's going to be 0.679%, or about 0.68%. So there's our percent ionization. Okay, and now our pH. So X is our OH minus concentration. Okay, so our OH minus concentration is 2.6495 times 10 to the minus 3 molar. So we can solve this a couple ways. So POH is the negative logarithm of our OH minus concentration, which is the negative logarithm of this value, which is 2.577. And so our pH plus our POH equals 14. And so our pH is 14 minus 2.577, which is 11.42. 0.390, so I guess 3 significant figures. So 11.4. Again, I just kept values until the very end. Okay, so then our pH is 11.4. Yeah. Okay, so there's our pH and our percent ionization. Looking through the solution as given here. As we can see here, they didn't make this simplifying assumption and use the quadratic equation. And so their value does come out to be slightly different. So 2.64 versus 2.649. So we're off in the second decimal place. If we now calculate our pH, though, it comes out to be the same. And our percent ionization also comes out to be roughly the same. Again, off in the third decimal place. But all in all, this solution is correct. In fact, the solution is probably a little more correct than what I did, but that's okay.